In this video, I'm going to talk about the static keyword. And for this purpose, I have created this class called car with three variables: wheel count, gear count, and the height of the car. We have a constructor that will initialize these variables. And we also have a display method that will just simply display these variables that the current object holds. In our main method, we have instantiated four objects of class car, and we're just invoking the method display. Let's try to run this program. Cool. Let's go to whiteboard and see how the memory management is done for this program. And do keep a note that we have four different objects created. So in our heap, we'll have four different objects created of class car. Now if you have noticed, there is one variable in this class whose value is common for all the objects, that is number of wheels available. For any car, the number of wheels available would always be 4. At least for the sake of explanation, let's assume so. When we're creating four different objects, we're also creating four different memory locations for the variable number of wheels. So this would result in creation of 16 bytes of memory, since integer takes 4 bytes of memory. This is not the efficient way of memory management. So what we're going to do is we're going to mark this variable as static. What that would result in is this variable will no longer be associated with the object. Instead, it will be associated with a class. And this variable will be moved to a new memory location called permanent generation. And whatever resides in the permanent generation space is actually associated with a class, not with an object. And now, instead of creating 16 bytes of memory, we're just creating 4 bytes of memory. And this memory location will be shared across all the objects. All the objects will be able to access this memory location and be able to get the value or even change the value. Now let's go back to our program and see how it's done programmatically. So every time we're creating a new object, we're also setting the value of number of wheels available. Now we can get rid of this. Of course, we'll have errors here because in our constructor, we're expecting a parameter, number of wheels available. Let's get rid of that. Let's make the wheel count static. Everything looks good. Let's try to run the program. Good, we got the same result. Now this particular program doesn't necessarily demonstrate the use of static keyword. Let me give another example. Let's say we wanted to count number of objects created for a particular class. For that, let me just get rid of this, or maybe I'll just comment this out with /* and */. We'll talk about comments in future videos. And what I'm going to do here is I'm going to create a new variable which is static int count equals 0. And in our constructor, every time we invoke the constructor, we're just going to increment the count. So every time we create an object, we're also invoking its constructor, and we're just going to increment this static counter. Now in order to display this, we can just access this variable in here count without using the object of this class. Like I said, when I mark a variable or a method as static, it's no longer associated with an object, it's associated with a class. So we can access this particular field even without creating an object. Let's see how it's done. System.out.println car, which is the name of the class, and the auto suggestion shows the count. Now let's try to run the program. Four, which is expected. Let's not make this a class variable. Let's make this an instance variable. And now let's try to run the program and see the output. Since this variable is no longer associated with the class, we cannot access with the class name. We can access with the object name, and whichever object you're going to use, we get its associated value. So I don't see any purpose in demonstrating this. Let's get rid of this, and we're just going to rename this back to static. Save the file. In the similar fashion, we can have static methods as well. And just as static variables, static methods are linked to a class, not with an object. Let me just demonstrate it. I'm going to create a new method here, which is static void static method, and I'm just going to do system.out.println count, and in here we can get rid of this statement. Instead of saying car.count, I'm just going to call that method car.static method. Let's save the file and run the program. There's one key point to understand here. This static method in here is not aware of the objects that are created with that class. Essentially what that means is, when we're calling a method using an object, we send the current object as a parameter implicitly. But that's not the case with the static method, because we don't have an object in first place. We're just simply using the class name. And with that being said, in our static method, we cannot access any instance variables. We can access only static methods or static variables. The count in here is static. If we get rid of this statement in here, we're going to get an error, and that's pretty expected. So from static method, we can only call other static methods or static variables. Now, can you try to figure out why main method is static? Pause the video and try to guess. Okay, let's assume that main is not a static method. Then somebody has to take care of creating an object of this class, and then we invoke this method main. Who is creating it? Nobody. The JVM way of solving this problem is, it will expect us to write a method with exact same name, main, including the case, and it has to be static, so that JVM can easily access this method using the class itself without creating an object. Because when we create an object, it's going to result in creation of memory location as well, which is not required. So that makes sense, right? Also, in fact, we've been using the static method throughout our course so far. Let me show you what I mean. The system.out.println. What is this? System is a class in which we have a static member, out, which in itself is a reference variable, and out.println is nothing but we're just calling the println method of object out. Hope that makes sense. Now, the static variable doesn't necessarily have to be a primitive type. It can also be a reference type as well. There is one risk associated with static variable. Let me show you what I mean. Since this static variable is accessible across entire application, from anywhere in the program we can change the value, and that will impact all the objects across the application, which is not intended. For example, I don't want anybody to change the value of number of wheels available because I know it would always be 4. So how do we handle this? We can handle this by using the keyword called final. Let's go back to our program. So instead of just calling it static int wheel count, I'm going to call it final static int wheel count. Now from the display method, I want to change the value of wheel count. It just won't allow me to do that. Now see the error. Cannot assign a value to final variable wheel count. Great, I guess we're good.